My name is Amanda Burma. I'm with FrogLogic, and we'll be going over automated GUI testing using FrogLogic Squish. And today the focus will be on iOS and Android applications. Just a few quick slides here, and then we'll get started. A little bit about FrogLogic. We are headquartered in Hamburg, Germany, but we do have presence in the US and Europe. We have a large and growing customer base throughout the world, and we're established in 2003. You can notice a few customers you may recognize, and we have more than 3,000 companies currently using Squish. So Squish is a cross-platform, multi-technology GUI automated testing solution. So that means that across different platforms or operating systems, devices, we can execute and record tests against your applications. It also supports multiple technologies. So across the different operating systems, whether you're on a mobile platform like iOS or Android, or you're on a desktop platform like Linux, Unix, Mac, or Windows, we can test natively on those platforms as well as a variety of technologies on those platforms. We're testing not only those technologies on the various platforms, but we're testing at the object level. We have object access. So we're GUI testing your application with actual access to your objects, meaning we can create intelligent scripts that will last a long time and become very easy to maintain over time. So with the accurate and flexible technology that we provide, you're going to have your record and playback functionality, but then we also have powerful scripting capabilities in a variety of languages: Python, JavaScript, Perl, TCL, or Ruby. You essentially pick the scripting language that you would like, and all of the Squish functionality exists in each of those scripting languages, and then you have the power of that scripting language as well. Not to mention our dedicated GUI toolkit awareness per technology, so you have access to your technology's API as well. In this case, for the demonstration today, that would be the iOS or Android APIs. We can test hybrid applications. So if your mobile application, for example, is made up of native controls, Android or iOS, as well as, let's say, web controls, we can test applications made up of hybrid technologies or multiple technologies. And again, we're testing them and have access at the object level. A few other features listed there, for example, our extensive integration and that we share our source code with customers. Now a little bit about the Squish architecture. Some of you may be familiar with Squish and some may not, or maybe you're familiar with the desktop editions versus the mobile editions. But if we take a look here, your Squish IDE is helping you generate scripts. We also have a complete command line interface that's possible through using the Squish runner, which communicates with the Squish server. And what the Squish server is doing is hooking into your application, or AUT, application under test, and is able to perform actions against that as a user would, interacting at the user interface at the GUI level and sending that information back to the Squish runner, from which we're able to then generate reports. Now, hooking into an application, whether you're hooking into the previous screen was your simulator, this is your actual device, we're not interfering with that application. In iOS, when you're working on device, there is a hook that you do need to enable when you compile that app. However, it's a minimal set of instructions available in our documentation, and that's the only way we can really hook in and see at the object level on an iOS device based on the Apple security. Within your simulator or emulator, in iOS's case, simulator, no changes like that are necessary. Any of the sample code that you can get from the Apple site, for example, of those apps will work in your simulator, or you can compile them for the iOS device. Now, Android, very similar. You have your emulator, and then you also have your device. We work interchangeably with both, whether you record on one, play back on the other, or vice versa, or a combination thereof. It doesn't matter because we're operating at the object level. I'll show you today partway through a script, I'll just change the orientation of the device and it will keep going. So if you were working with, let's say, an image-driven testing tool, that wouldn't be possible. Or if you were only surface seeing those objects versus seeing and hooking into the actual object level, you wouldn't be able to do that. Now for test script execution, because that was more on the recording side, many times the execution is done without the IDE. When you're first developing things, you may execute from the IDE, but you may also use our command line interface or one of our number of integrations that we offer, which may then make Squish part of your build process or part of your application lifecycle management process, allowing the Squish runner to communicate over your network to the various Squish servers. And from those Squish servers, each of those, based on the technology it's working with, is hooking into the application under test and execute your scripts, returning the information about the execution back to the Squish runner, which generates the reports. We generate those reports in XML, and there's a number of different output options, as well as the integrations that we offer and their output options. Now, here's some of the integrations that we offer, and the complete list of integrations is also available from our website. So enough slides. Let's dive out of the slides here and into the demonstration. And what we have in front of us right now is Squish. Now again, if at any point you have questions, please do ask the questions over the question answer area and I'll get to those as soon as possible. If not, I will get to them as soon as we've completed the demonstration. With our Squish IDE, the Squish IDE is based on Eclipse. If you're familiar with Eclipse, this may look familiar to you. You can use it directly from Eclipse, or you can use the IDE that we ship with. Now, when you're working with an application, we're going to have a test suite. So your test suite is going to be your collection of test cases, as well as any test suite resources or global scripts associated with that test suite. So your collection of tests, test suite resources might include common functions, scripts, data, or verification points that you'd like to share across your test suite. And then you also have global scripts. This is, for example, in JavaScript, and you can then pull in other JavaScript scripts that you have and use those within Squish as well, because that was the scripting language selected. Based on the other scripting languages you want to use, the same options are available. So if we take a look in here, we have a test suite that I created. The test suite is going to be using the Android edition. And so what we have here is a list of any Android device currently connected to the machine. So I'm going to unplug and plug back in my Android device. And I will show that to you over a webcam here shortly. But first we'll take a look at it over the emulator. So when you have your emulator connected, or if I click refresh, it will have my emulator and my device showing all items available that are connected. I'm able then to specify in my test suite settings which application or package I would like to execute those tests against by simply clicking New, browsing to my APK, so your application package there, browsing to your Android APK, selecting then, and I've already set this up in advance, but I'm walking through it with you so you can see how to do it, then the deployment device that you would like to execute or record against, and select Instrument and Deploy. Now I said to do that against my emulator. So my emulator right here is available. It returned back to Squish, so it's instrumented, ready to work with. So those are my test suite settings, unless you're switching between different applications within the same test suite. It's kind of a set and forget type setting. So what do we have here? Let's first create a new script, and then I'll show you some other scripts that I created. So I'm simply going to click New Test Case. It adds that to my test case list. And from there, I'm going to click Record. Now, because I've indicated that I want my test suite in JavaScript, the script that it's going to record will be in JavaScript syntax. So we're able to see here, let me minimize that, my application under test. It automatically opened that up within the emulator because I said to use the emulator. And so everything that I'm doing, here's my control bar. Everything that I'm doing, it says it's recording. I'm going to perform an action. I'm going to click, for example. I'm tapping on an object. Okay, and after that, I do have the emulator set up to use my keyboard instead of um, using the on-screen keyboard. It's just an option that you have available in emulators. I'm not sure if you do a lot of emulator versus on-device testing. I'll show them both to you today. Both have their pros and cons working with the emulator because it's not your actual device, so we do make them both available. So let's click Save. It's recording again all of my actions. Now, in addition to recording actions, which is important, does the product do what we're expecting it to do? We have our expected result that we want to reach. So for the expected result, using our control bar up here, I'm able to create verification points. Whether I want a verification point against a specific object and its properties to verify the data is there that I expect. I want to create a screenshot-based verification point on one or more objects. So it's still finding the object based on the object properties, but comparing screenshots. And then we'll also have here, the ability to verify an entire table's contents. So let's just create our object-based verification point. I'll select it here, and that's going to return me back to Squish. From here, I can give my verification point a name. That way, if I want to store it as a test case or test suite resource, I'm able to do so. And then here down below, I can see my application object tree and my properties. However, instead of navigating through that manually, I'll use the object picker, which will return me back to my AUT, my application under test. And this is where I can come and I can select an object I'm interested in. So we can see the object that I just selected and its properties. Now this is very important. The fact that we can hook into the application, see the objects, see the object properties, and verify those. Now you'll see after I verify a few objects here and click stop and we look at the script, how this is also being used to help identify and locate objects so that your script can interact with them as an end user would. So I've just selected to verify the text here. You can verify one or more items. For example, is this item enabled? And that's going to add that to my verification point up above. I can select here to either have it be a script-based verification point or a property verification point. The property verification point will then be saved as a test case or test suite resource that I can then easily call again and again from other test cases. I'm going to insert just the script line so you can see that one. So we're giving you flexibility in the functionality here based on user experience or also based on what you want to do, what your intent is with those verification points. So we interacted with the application. I'm going to come back here and click stop recording and we can see our script. I hope everyone's following along okay. No questions so far. So we have our script. What is it doing? It's starting the application that we indicated. And then you can see all the different actions that I performed while recording, including, here's my verification point, the fact that I want to compare finding this object, look at its text, and make sure it's equal to Burma. So not only does it need to find the object, it also needs to compare the text of that object. Well, how are we finding these objects? We have an object map. So if I right click on any of these symbolic names or nicknames almost for an object in my script, right click and select Open Symbolic Name, I'm going to have the ability to look at that object as it was captured by Squish while I was recording. So any object I interacted with was added to this object map. And then I can see that object's symbolic name, I can see its hierarchy, and I can see its real name, the collection of properties that Squish is using to properly and uniquely identify that object. So you can see if you're familiar with any of the Android API that those are properties. These are common objects of an Android specific object. So that collection of objects, now if it's changing, let's say that you're working with something that's continually changing and you need to handle that change. Well, what you can do is you can use either an equals here. Let's look at the text. Equals a wildcard or a regular expression, meaning if this edit address text were changing, maybe between different versions that you have, you've changed it to edit address, to modify address, etc. You can simply come in here and make that change for a new version. Or if this were more dynamic, you could then incorporate a wildcard or regular expression so that Squish can still find that object even among those changes. A common example I use of dealing with such changes is a title bar of an application changing based on what I have open. Test management, for example, up here remains the same, but the rest changes. So test management, that portion of the string, as well as the other unique properties of that object, will be used to find the object. So that's how we're finding these objects. It's keeping your script simple so that you make a change in the object map, and any place that object is used throughout your entire test suite doesn't have to be updated at the script level because it's looking back to that object map. It's going to save you a tremendous amount of time using your scripts going forward. So let's just run this one that we created. Now over GoToMeeting at times it can be a little difficult to keep up, for GoToMeeting to keep up with all of the images that are being sent over the meeting. So I'll run that one more time here. And you can see that obviously I'm not doing it. It's executing quite fast. We're using the emulator and everything's passing. Okay. So we can see in our test results down here, we not only have our test summary, which indicates the duration in seconds, the number of tests executed, number that passed, but we can also see our results, the detailed results of any information we log to the report. We had 2 verification points, that logged to the report. You can send other logging information, capture object information, capture a real-time screenshot, for example, and send that there as well. So we created that new script, and let's take a look at a very similar script. This one's going to be just like the one that we created. One of the things in either of these scripts that I failed to mention so far is this wait for object. That's part of the Squish API along with some of these other commands that you'll see throughout the demo and are available detailed in our documentation. But this wait for object is automatically incorporated when you record, allowing Squish to intelligently wait for an object. So what happens when it gets to this step is it calls this wait for object function, looks at this object, again looking up the details in the object map, and checks to see if that object's there. Now there's an optional parameter here. It's in milliseconds. So when it's hidden, the value is 20,000 milliseconds or 20 seconds, meaning Squish will wait a maximum of that duration for the object to appear before sending a failure back to your test results. Or if the object's there before that duration, it will continue, allowing the script to continue as fast as possible without going too fast for the application. Now, this is a linear script. We worked with that. Let's take a look also at a script that I may divide, for example. You're not only going to create scripts, you're probably going to record in what we call snippets or small segments of script and then modify your script to become more intelligent. For example, in this case, some common elements of the script were extracted into a separate function, this above here, and then an array was created, iterating through those steps, each time adding new information. So instead of a linear script, we now have a data-driven script. Now this is using an array just for demonstration purposes, but this could come from an external data source, for example, a spreadsheet, a CSV, TSV file, or a database. And it's going to run through, and now instead of checking one set of data, we're able to check various sets of data. So you can very quickly and easily, with some simple scripting, implement a data-driven script. Now I've been running these against the emulator. You probably want to see that on the device as well. So the next time I hit run here, I'll run it on the actual device. And then you'll notice that the device I have in an alternate orientation when I show that to you here. So here's my device. And the reason I show most of the demo from the emulator or simulator is because devices are a little harder to see. But from the device, we can see that's in a horizontal orientation. I'm going to use an even different script where I extracted the function to a test suite resource instead. And by placing that over here, I have all these different functions. And because of the way I've set them up, I've enabled the IntelliSense to work not only for the Squish API, but also for my functions that I created. So I have then IntelliSense for my functions, helping, especially if you're working in a group of testers, you to collaborate and reuse a lot of the common logic. Okay, so let's run this one, but instead of against the emulator, I'll simply specify to run it against my device. And I'm going to click run over here. And let me see if I can't zoom in on it a little bit so that I don't have my zoom tool loaded. But you're able to see, while it's difficult to see some of the detail, that it's executing the same script. I can run the script that we just recorded and execute that. It's in a different orientation, but it doesn't matter because we're finding the objects based on the object properties. If I took the time to go into the code and move those objects around, it would still work. So we've seen the different orientations with the same scripts. We've seen data-driven scripting. We've seen how we can interact at the object level on a device in an emulator. And let's switch to iOS now. We'll turn off my webcam here. I don't have an iOS device available right now to demonstrate that from, but it's the same concept. So from Squish, where I'm opening up the iOS edition, the IDE is going to look just the same. It's going to operate just the same, just pointing at a different toolkit set. So we have my test suite here. Let's close these other scripts. You can see I can have multiple test suites open at a time. And from this, I have the option to work with either the simulator, the iOS simulator, or a device as well. Now I just have a simulator connected. So for example, if I launch this AUT, this application under test, set up the same way or very similar to how Android is set up, browsing to the app. And then Xcode launches the simulator. So I've got my simulator and I've got an application. One of the things you just saw me do here is I just ran the application from Squish without recording or playing back. So that let's say that I want to inspect and play around with the application a little bit. As we did with the verification point we created before, I also have the ability to simply spy objects, come over to my application, select an object, and then that returns me back to Squish where I can see and work with those objects. So whether you're recording, playing back, or simply just examining and playing around with your application, you're able to see those objects, see the of properties within those objects, and what's available to you. Now, why might that be helpful? Not only is it used for finding the objects and interacting with them, but you may want to capture information about the various properties, states, statuses, or values associated with the different controls, the different properties at various points in your testing. Now let's take a look. For example, here's a script that I created to show you slightly different logic. I also have a touch and drag in here. We do support gestures within our testing. And I also included in here, I'm clicking on an object. However, if that object is still visible after I've already clicked on it, this should be indented here. Well, I guess not really. Then what you have is the ability to check and do some troubleshooting within, or some refactoring of your script to better handle exceptions, unexpected things. In this case, I simply have an if, but you could have a try-catch statement, for example, so that in the event anything happened that was unexpected, you could then capture what that error was. You could capture, for example, a screenshot, which I've turned on here for the error, log a warning, log a fail, etc. So you have more logic that you can incorporate. Well, let's run this one against the simulator. So it's going to work just like the Android edition worked, except it's opening up the simulator versus going to the emulator. Again, you can do all of this testing on device as well. So one of the things I wanted to show you is, while this object right here is available and Squish clicks on it, it wasn't reacting. So there's an issue with it reacting. Sometimes it was requiring multiple clicks. So what I did is I am checking to see that after clicking, if it's still visible, I'm then clicking it so my test can proceed checking the other items. However, I'm logging a warning to myself to know that, hey, this is something I may need to investigate further, maybe do some manual testing on it, or maybe I need to look at the search parameters of the object, or why this object just isn't reacting the way I expected. But I'm able to allow my script to keep going and capture that. Now, if I change this to a test.fail instead of warning, one of the things I have turned on here is, if I encounter an error, so a scripting error, let's say a syntax error, it can't find an object, or if I have a verification point fail or log a failure, I'm going to capture a screenshot at that time. So not only can I capture data um, from my application, I can also capture an image to see what it looked like at the time that that error occurred. So for example, if this is not true, I'm going to click the object again, but report a failure. Maybe prior to clicking the object, I also want to collect more information about that object. My button. So what I'm going to do here is set that equal to my button. I'm going to do test.fail, and then I'm also going to do, oh, it doesn't want that in there. Well, from there I'll be able to see my button, and I can incorporate that in here as well. I'm trying to remember the JavaScript syntax here for, there we go. Hopefully that's the proper syntax for JavaScript here. I'm typically working in Python, but off the top of my head. And then what it's going to do here is click, it's going to return the message as well as a string of all the properties of that object. Now I could select individual properties to look at, but I'll be able to see some information about that. Now the other thing I'm going to do that you could do from the script level as well is, as this script is running, I'm going to change the orientation partway through and make sure that if an end user were using this tool and they all of a sudden decided they wanted the orientation to be different, that it would work. So partway through the script, I'm changing the orientation. Again, you can automate that instead of doing it manually as I did, and see if the objects are still found, if it's still working in that orientation, everything like that. Okay, so maybe this is str. The idea behind this here is, it's going to log the string. It's going to also log a screenshot at the time the error occurred. And so you have multiple sets of information about that particular object. Now we can make this fail even more. You saw a scripting error. If it can't find an object, what does it do? Now the important thing with this is, I've recorded these on the simulator. I can switch between the simulator and an actual device without issue. It will all play back just the same between the device, between the simulator. Now let's say I'm troubleshooting some things and I'm not quite sure, what's going on, why something is happening. We also have the ability to set breakpoints. For example, let's set it here. Um, and then we can see any variables that exist, those values. We can spy objects right at that point. So with my breakpoint set right here, I'm going to run. And then when it gets to that breakpoint, it will return back to Squish, at which point I can step through my script one step at a time, step through functions, over functions. I can view objects. I can even send messages to the Squish script console to see if I'm getting information back. So remember this? I wasn't quite sure what the syntax was. Well, I've got a script console. Why not play around with it? So for example, I have my button over here. It's my variable that I have. You can see all the properties. I captured that. So let's do something over in the script console, very similar. So I'm going to take this object. I'm going to look for that object. And actually, it's going to fail to return it because it already clicked. So we'll find a different object here. I'll look for this object. And you'll notice I put in the wait for object. So it is going to wait that duration, the 20,000 milliseconds, and then say, hey, I couldn't match the properties. I couldn't find that. So that's the type of error you may have returned to your script. But let's do this. So I've got that one. I can see I'm getting the variable, the value. Now, what if I wanted to convert this and I wanted to make sure my JavaScript was correct? I can test things from here, and so that still isn't the correct syntax, but you get the idea. From here, test.fail, these different actions, I can wait for an object and make sure the object's available. I can work with all of that information. For example, this variable's text value is set to null, so it doesn't have a text value. Anything available from your application's API is going to work within your script. So all of those different API commands that you have will work from here. All of your different application objects. See, we can see all of those objects. Again, we can go out, use the object picker, select an object of interest, and see all the properties of those objects. Those are all the properties I could pull from the script console as well. So then I have the ability to continue stepping into, stepping over my different functions and troubleshooting what might be incorrect and how to resolve that within my script. So we can just click resume here. It will continue executing and we encountered an error. Now, another thing you can do from a breakpoint is instead of maybe you're not troubleshooting, maybe you forgot to record a few steps. So you can set a breakpoint. Let's stop the debugger here. We'll go back to the test management. And from here, I could set a breakpoint where I want to begin recording. So when I click run, it's going to run to my breakpoint. And this is where I'm going to be able to begin inserting steps that perhaps I forgot or I just didn't record the first time. So again, I'm paused. I have all that functionality available I had before, but I can also right click and record a snippet. Another thing before I record that snippet is I can right click on an object since my application's running and take a look and see if Squish is able to find that object, check its existence, highlight the object. If you were working with an object that's changing, or you're having trouble locating that object and you were working with the real name and inserting a wildcard or regular expression, this is a great way to be able to test that by making changes here and checking its existence, highlighting the object to see if that's the object you indeed want it to find using that criteria. But in this case, we'll just record a snippet by right-clicking, selecting Record Snippet, and now anything I do from here, I can see when I click Stop. So I recorded a few actions. We'll click Stop. Now, obviously, you want to make sure that sequentially those are accurate, and we can see the actions that I just recorded and added to my script. So typically your scripting is going to be a combination of recording and refactoring or modification of your scripts. Okay, at this point, I'd like to open it up for any questions, and I'd like to thank you also for your time attending the webinar. While I open it up for questions, I will also go back to my presentation and show you some additional information that I have about Squish. So just a little bit of a reminder, cross-platform multi-technology object level support. Again, that object level support is very important, especially on these mobile devices. There's a lot of tools out there that are creating rapid test suites using image-based technology, but your apps are going to change, your apps are going to evolve, and orientations change, um, cha working against different resolutions, etc. With this object level support, you're going to have one set of scripts to do that instead of maintaining and having to update based on trivial little changes or large changes to your application. Now, you saw the power and the ease of use of the IDE based on Eclipse. A lot of features in there, a lot of functionality, but also a lot of interaction from the UI standpoint, recording, playback, spying different objects, working with that object map. Now, one of the things we didn't cover today visually was any integrations, but we have a complete command line interface that you can use, as well as extensive integrations for incorporating Squish into your entire application lifecycle process. And of course, our source code is also available to customers to be able to extend Squish the way they would like as well. So for questions, I'll again stay on the line a few more minutes for questions. And then there's also documentation and our knowledge base available at these URLs that you can see here, and our website,